Alrighty, before we get to what we're talking about today, I want to revisit this question from Friday because somebody asked me a question, and this is one reason I really like when you'll ask me questions, because sometimes I don't know why you're confused about certain things, or I don't realize that you took something I said or did and interpreted it in a different way than what I intended for you to interpret it. And then I can get to the root of, oh, this is why you're confused. Maybe you're not the only one. Let me make sure I clear it up with everybody. So when we were talking about overestimate and underestimate, and I drew this line here, and I put little points on there, which I didn't even line up very well. But I had somebody come and ask me a question on a different one, and I have no idea what the numbers were on what they were doing. But it looks something like, I don't know. Let me just use those same ones. Looks something like this. Oops, let's pretend like that's a 12. And then they said, I don't really understand how I'm supposed to know from this if it's an overestimate or an underestimate. So I asked them like what the intention was with their numbers, because it was like almost written like a fraction and not like with points and kind of where I was going with that. And they said, oh, I thought it was some formula that I didn't understand. So this was not in any way a fraction bar or anything else. I purposely didn't draw everything because I want you to get in the habit of just kind of sketching things. So let me kind of re-explain what I was doing here. So this pink line that I drew, that is like my my regression line. Okay, just I don't know what it looks like, but just something like that. It actually, that's not even correct because that has a, no, it does have a positive slope. Anyway, it doesn't even matter if it's accurate. But here's what I didn't draw, because we don't need a perfect graph every time, but I want to make sure everybody understands what I'm doing here. So this is like my x and y axis. So this is my x value. And in this case, this was for this one, this was x equals 50. All right. So what I was doing was this is my regression line. So for my regression, it was about 12. And then this 20, this point really should be right above it, but I guess I'm doing it off to the side and I messed it up. And then this is your actual one that is 20. And so then we were looking at, well, that means the line is an underestimate because this is my actual point. Okay. I just didn't do the entire graph. There was no weird formula or anything else going on there. Okay. Everybody okay with that? Any questions about this before I move on? Because it was a very good question. And there's other things sometimes when people ask me a question, I'm like, oh, I see why you would think that. I should clarify that. So, all right, good deal. All right, let's move on to what we're doing today. Then you have this new piece of paper. This goes on page 64 also when we're done. So this says, while driving down a dirt road, you punctured the tire of your truck. The table below shows the pressure Y measured in pounds per square inch, PSI, if air in the tire, I guess is what I should say, at any given time X measured in seconds after the tire was punctured. So everything it just said with units and whatnot is right here, and if it wasn't, then I would want to make sure I wrote down my units and stuff next to it. A says find an exponential function in this form that best fits the data. So we're going to do that with our calculator. It is giving me this form to tell me that there are no, vertical, or there's no translations at all, no horizontal compressions or anything. So I'm going to assume at this point that you don't need me to talk you through how to do that. So, I wrote this on the board. I even remembered to change it this morning. Pay attention when you come in so you know what you need. I'm going to assume that you can get yourself through this. Go ahead and find the regression. If I am wrong about that, let me know. And I will walk you through it. Otherwise, I'm just going to let you do it. So that's value. So I need one to look at. Once you find it, go ahead and write it down. Remember, if you can't see it, you might need to arrow back up in your data. Once you find it, get it written down for me. Let me know if you have any questions. Any questions at this point? We're all experts at typing in data and getting our regressions at this point? Okay, think about the first day we did it, how confusing it was, and all those buttons we had to push. It's like no big deal now. All right, so then B says, plot the equation and scatter plot on the same screen. Does the exponential function fit the data points, and explain? Does B say anything about residuals? No, so we're not going to go down that road just yet. But it does say to plot the scatter plot and the equation. So on the calculator, I can't do it here, I know, so I'm going to need to add a page. What am I adding? How do I get the scatter plot? 5, data and statistics. And then you go and you fix your axes. It'd be nice if there was some sort of default for that, but there's lots of things you can do with this, so that's why there's not. Now, I have my scatter plot. How do I get the curve on here too? What do I have to do? Menu, 4, 6, 8. So it's asking us, based on this, does this look good? Basically is what it's saying. I think it looks pretty good. Would you agree with that? It might look just as good if we did a quadratic. We don't know at this point, but it's not asking us that. It's asking, does this look pretty good? In so many ways. So we can come over here and say, does the exponential function fit the data points? We can say, yes. The let's see, the data points fall along the curve of the exponential regression. If you were to write that out yourself, do your words have to be exactly like mine? No. Chances are pretty good they won't be. Chances are pretty good my words won't be the same every class period today. It's just how my brain works. But I will at least have said the same general thing every time. Okay? What questions do you have? All right. So then it says, using the model, what was the pressure of the tire before it was punctured? So I want the pressure before it was punctured. So what is it asking me to find? 0. Just 0? What is 0 going to be? Is 0 the pressure or the seconds? The seconds. So 0 is x, right? So basically I want y of 0 hat, which is one way to write it. We write that a little bit differently in calculus, but we don't need to get into that. That'll work for us. Do I type those decimals back in up there? And type in that equation somewhere? No. I'm going to kick you out of my room if you do that. Where do I go in my calculator? What do I need to do? Calculator screen. 1. And then I want to find F1 of what? 0. Very good. So that gives me 33.8795. 33.8795. And what are the units here? PSI. What does PSI stand for? Pounds per square inch. If you're not a tire expert, how else would you know that? Says it in the question. Absolutely. All right. We all good so far? Any questions? All right, so D says, plot the residuals, explain what you see in the plot. What does it tell you about the validity of your regression function? Okay, so what do we need to do on our calculator? Plot the residuals, right? Is this the screen I need to be on to do this? No. Okay, so I need to be on that second one we had. So remember, you can click up here if you like the mouse thing, or you can do Control left and it takes you back there. So now we do menu 4, 7. I want to show the residual plot. So what do you think? Do you think the exponential is a good plot for this? How would you describe what's happening here? Do you see a true pattern? No? Okay. So I would say then, it says explain what you see in the plot. So I would say the residual plot does not show a pattern. Okay. So I explained what I saw. Then I can do this. What does that mean? Therefore. Or you can write out therefore, or you can say so, or however you want to do it. But therefore, the exponential regression model is good for this data. Something to that effect. Any questions at all? Phenomenal. All right, let's look at this next one. So a set of data has an upward trend shown in the plot below. So here's the actual data plot. It's not clear whether the best fitting function is linear or exponential, right? You can kind of see how maybe you could get a linear in there. My line doesn't even look like a line. Or maybe it could be exponential, right? Or maybe it could even be quadratic. You just, kind of reason through any of them. So we're looking at the residuals here. And with the residuals, do you see a clear pattern in the linear one? Yeah. I would say even if you can't really, you've got high on these ends and then down here, so that kind of looks like a little, looks like a weird smiley face now, but you kind of see a pattern because it's the same on the outside and on the inside here. So I would say this plot shows a pattern function is most likely nonlinear. Because, yeah, it gave me something else, but if that's all I had, I would say, pattern. What is wrong with me in this word? Pattern? Function is most likely nonlinear. Okay? Does that make sense to you? So basically saying this one, linear is probably not what I want. Then what do you think about exponential? Do you think it has a pattern? No. Okay, so I can say that this plot shows no pattern. And exponential regression would be good for this data. You could probably say that better than me with a whole lot less words, but see what comes out of my head. All right. Any questions at all? Beautiful. Flip it over. Okay, so an exponential regression was used to model a data set. The residual plot for the exponential regression model is shown above. Which of the following is the best conclusion about, so I want the best conclusion about the appropriateness of the exponential regression model and this corresponding residual plot. Okay, so let's just look at the residual plot. This is for our exponential. So do you think that that would mean that exponential is good or not good? Do you see a pattern? No pattern. So would exponential be good then? Yes. Okay. So this says, so A says it's not appropriate and B says it's not appropriate. So I think we can eliminate those two, right? So then you read C and D and decide which one you think is the right answer. Is appropriate, and then the difference here is this one says shows no pattern, show a pattern. What's the answer? C. Everybody good with all that? Beautiful. Okay. A group of AP Pre-Calculus students used a set of data to create a linear, quadratic, and exponential regression models. After creating the three models, the students created a residual plot for each model type, see above. Based on the three residual plots above, which model was most appropriate for the data? Give a reason for your answer based on the residual plots. So it can't be based on your feeling or, you know, an alien told you or something. It has to be based on the residual plots. So which one do you think would be best? Exponential. All right. So give it which, so I would say exponential regression model would be most appropriate because, and then you fill in the rest there. I just put because the residual plot shows no pattern. And whatever you wrote, if you basically said that, then you're good. Okay. Are we good? Any questions? Beautiful. All right, let's look at example 8. Mr. Passwater hopes to make it to the Guinness Book of World Records by painting the world's biggest mural on the sides of several downtown buildings. His mural will consist of many painted circles of various sizes where each circle is painted a different color. He wants to create a model to determine how much paint is needed in quarts for a circle of radius r in feet. Okay? So should Mr. Passwater use linear, quadratic, or exponential model in this situation? Explain your reasoning. So what do you think? We got to figure out how much paint we need. What kind of model do you think would make the most sense? Now, I know for a fact you have had to figure out questions like this in junior high. You're going to paint a wall, and you need to know how much paint you need. What do you need to know about the wall? How big it is to find the area, right? And here's how I know this, because if we go to a training where it's like K through 12, or even if it's for high school, but it's like all contents, they never really talk about math. They talk about everything else. And then if they want to try and connect it to math, or if somebody's like, that's great, how in the world would you use this in a math class? They usually say, oh, well, you can kind of use perimeter or area. And I'm like, oh, that's great. Welcome to junior high. how would you do this in a high school class? But that's something those are the kinds of questions that you had. So this is almost just like a flashback to junior high with the concept that we're connecting here. It's because it has to do with area, right? That's why we would use quadratic. Okay, so we can say Mr. Passwater or Mr. P should use a quadratic model because he needs to know the area of the circles. Circles to determine how much paint. Does that make sense? Okay. After creating his model, Mr. Passwater uses it to purchase different special paint colors to use on his mural. In this situation, do you think it is more appropriate for the model to underestimate or overestimate the actual amount of paint? What do you think would be better here? I heard under and over. Somebody want to justify over? So he has leftover paint, and so what? So we didn't run out, right? Somebody else, did I hear underestimate or did I not? Somebody want to justify that one? I think overestimate, because you don't want to run out, right? You also don't want to have a ton of extra, but you don't want to run out. So I think overestimate makes the most sense. So okay, it is more appropriate for this model to overestimate so Mr. P doesn't run out of paint. Any questions at all? We all good? All right. That goes on page 64 with the other two from Friday.